Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. Today's question is intersecting intervals. In this question, we're given two arrays A and B, both of length n, and we define f of A comma B as following. So we can choose two intervals L1 R1 and L2 R2 such that both Li and Ri are in between 1 and n, and their intersection is non-empty. So they share at least one point in common. Now, the score of the intervals is defined as the summation of all the elements from Li to Ri in A of I, and the summation of all the elements from L2 to R2 in B of I. So basically, L1 R1 represents the subarray of this A, and L2 to R2 represents the subarray of array B. And we need to find the maximum possible score under the above constraints. So less formally, all we need to do is we need to find the maximum intersecting subarray sum of the array A and B. So let's say we have A1, A2, A3, A4 dot AN, and we have another array B1, B2, B3, B4 dot BN. Then we need to find some intersecting subarrays which have some elements in common such that the sum is maximized. Now let us see the constraints ones. And the constraints are given that the test cases will be in between 1 and 10 raised to the 4. N will be in between 1 and 2 into 10 raised to the 5. AIBI will be in between minus 1 billion to 1 billion. And the sum of n over all the test cases would not exceed 2 into 10 raised to the 5. So now let's see the sample inputs once. So the first input, we have 1, 3, minus 1 and minus 1, 3, 1. So the maximum sum that we can get is this 4 plus this 4. So this have this element in common, and the sum is equal to 8. In the second sample input, we can select this as a L1 R1, this as the first subarray, and this as the second subarray, and the total sum is 2 minus 1 plus 2, which is 3. In the third sample input, it's best to choose just this much, so they have one element in common. The sum is minus 8, which is the maximum possible. In this fourth input, it's better to just select all the elements, so the maximum sum is 12. And similarly, you can just figure out the maximum possible sum for this, which would turn out to be 30. So now let's move to the solution. So notice that we are given A1, A2, A3, A4 dot AN and B1 and B1, B2 dot till BN. And we want that each, like there should be at least one element in common, and we just need to figure out the maximum possible sum. So let's say this is the element we are enforcing to be common, right? So what we'll do is we'll force one element to be common. And if we're keeping this element to be common in both the arrays, then what is the maximum sum I can get in the array A by choosing this element? And what is the maximum possible sum I can get by choosing this ith element in the array B by choosing some more elements towards its left and towards its right? And if we can calculate that effectively for each index I, then we can calculate our answer easily, right? Because that will be the maximum for all the arrays. So one approach which we can use would be using prefix suffix along with binary search. Or another is using something similar to DP. So what we can do is we can calculate that for each element, what is the maximum sum I can get to its left, which would be stored in the prefix, and what is the maximum sum I can get towards its right, which would be stored in suffix. And this prefix A would store the sum for the array A, the suffix A would store the sum for the array A, and the prefix B would store for the array B. Now, what prefix I would store? Prefix I would store that including this element, what is the maximum sum I can get towards its left. The suffix I would store what is the maximum sum I can get towards its right. And I'll subtract A of I because this element is getting counted twice, right? Similarly, in prefix B, we'll calculate what is the maximum sum we can get in this much part. In suffix B, we'll calculate what is the maximum sum in this part. And again, we'll subtract B of I because this particular element is getting counted twice. And this would be the total sum, right? Now, how can we calculate these arrays? So I'll just tell how to calculate for this prefix, and the for suffix, it's going to be exactly same. So consider this as our array, and this is let's say array A1, 2. This is let's say array A. Now, what will be the maximum possible sum to the prefix of this element? This would be A1 only, right? Because I need to include this element A1. what would be the maximum for this element A2? So including this A1 would reduce our answer, right? So can we say that it would be max of this prefix A of I minus 1, comma, 0, right? Because if this prefix sum is already negative, then it's useless to add that element, right? So can I say it would be 0 plus 7 up till here, right? Because including this only 7 is best, right? Now up till here it should be 7 plus 11, that is 18. Now up till here, is it better to include this or not include this? So we can have 18 minus 4, which is 14. That is the best we can have, right? Now up till here, what is the best possible sum that we can get? It would be 14 minus 100, that is minus 86, right? Up till this, what would be the maximum possible sum? It would be only 20, right? It's not useful to include this element at all, right? And up till here, what would it be? 20 minus 5, that is 15, right? Because that's the maximum sum we can get up till here. And so in general, for any index I, it is equivalent to max of 0, comma, prefix of I minus 1 plus A of I, right? And this is how we can calculate the prefix A. Similarly, we can calculate prefix B. And similarly, we can also calculate the suffix by just running the loop in the reverse order, right? And that's pretty much the whole solution as well. Now let's see the solution code in C++ and Python. So this is a solution in C++. We are defining LL to be long long, and we'll be using that everywhere. We are taking in the input of our array A and B. We're defining prefix A, prefix B, suffix A, and suffix B. We're calculating this prefix and suffix arrays. So we're defining prefix to be this, and prefix A of I is equal to max of 0, comma I minus 1, and similarly we're calculating prefix B. And in the exact same way, we're calculating suffix, but the only change is we're running the loop from n minus 1 to 0, and we're just doing I plus 1 instead of I minus 1. We defined our answers to be minus infinity, and we're just calculating our answer to be max of answer, comma, prefix plus suffix minus AFI plus prefix plus suffix minus B of I, and we're just printing that answer. And yeah, that's pretty much the whole solution in C++. Now let's see the solution in Python. So we'll run a loop for each test case, and for each test case, we'll be taking in the input of N, A, and B. Now these are our 4 prefix arrays: the prefix array, the prefix B array, the suffix array, and the suffix B array. Now we'll be calculating the prefix degree. So how will we do that? We'll define prefix A of I to be A of I, prefix B of I to be B of I, and prefix A of I would be plus equal to max of 0, comma, prefix A of I minus 1, and similarly for the prefix B array. And we'll be calculating the suffix array in the exact same way, but the only difference is that we'll be running the loop from n minus 1 to 0, and we'll be doing I plus 1 instead of I minus 1. We'll define an answer to be minus infinity, and at every step, we'll take the answer to be max of answer, comma, prefix plus suffix minus A of I plus prefix plus suffix minus B of I. And then we'll just simply print the answer, and that's pretty much the whole solution. The time complexity of this solution is big O of n, because we're just running these 3 loops of big O of n size. And yeah, that's pretty much the whole solution. I hope you liked it. Thanks. Bye bye.